Hello, and thanks for joining us today for the latest Technology Networks webinar, Multi-Site LIMS Harmonization. I am Jack, Editor for Technology Networks, and I'm here to moderate the event. I am pleased to have Randy Hice, Manager of Global Strategy at Abbott Informatics, joining us today as your presenter. Randy joined Abbott in 2009 after serving as CEO of the laboratory automation consultancy, Laboratory Expertise Center, since 1996. Prior to joining LEC, Randy served as a senior software specialist in LIMS at Digital Equipment Corporation, as well as manager of bioassay chemistry at the International Research and Development Corporation. He has also contributed a monthly laboratory automation column for Scientific Computing magazine since 1996. Warm welcome to you, Randy. Following the webinar, we will have a Q&A session, and we'd welcome any questions that you may have. To ask a question, you should enter your question into the box on the left-hand side and click Submit. We'll answer as many as possible during the time available. Any questions we don't have time to get to, we'll be sure you are contacted offline with an answer. If you experience any technical issues, please use this box to request support. I will now hand over to Randy.
Thank you, everyone. Thank you for attending. I thought by way of introduction, as Jack mentioned, looking back into the history of the harmonization process and the necessity for it. I did work for Digital Equipment Corporation. In the late 1980s, they decided to get away from an application technology. And suddenly, we had a lot of customers that were deployed on the LIMS SM platform that was hosted by Digital. We were suddenly faced with a lot of customers having to move to other vendor products. And we had to sit back and try to devise a strategy for the best way to understand the requirements and the ability to do that. What we quickly learned in the early stages of those projects were that customers would always refer to the frame of reference that they had, meaning the current application. And we started to see a lot of arguments between groups about how best to define the requirements for the next system. And we decided that the best way was to abstract ourselves from the current state environment, meaning the LIMS system that they had deployed, and move up to a business layer. And that's what we'll be talking about today in the process for executing it. So as a result of that strategy, we've refined it over the years and have used it in dozens and dozens of accounts. I personally have been involved in about 150 account projects over the years. So let's look at what the challenges are. Companies these days are trying to consolidate and simplify their testing operations. And there's been a trend, it's been kind of a gravitational pull by the customer base actually towards centrally served browser access systems, largely due to the simplicity of supporting a browser access system and getting away from the client server systems. And what was once a desire is now a requirement. What we mean by that is that in the days of client server systems, companies always believed that was probably a good thing to have a consolidation of processes. And they chose this for the reason that from a matter of support, from a matter of training, from a matter of transportability. And what I mean by that is companies that had multiple sites, if they had similar processes between sites, they could literally move people between different geographical sites and they would be able to work instantly when they were moved. From a support standpoint, not having to support 5 different systems or whatever, or even 5 different permutations of a similar system, greatly facilitated the whole support picture. And from a training aspect, you're not training people on 5 different systems or systems indigenous to specific sites. So you could train on one system, and we do realize that there are differences sometimes that are required between geographical sites. This is something we'll address in a few minutes. But overall, it was the customer base that started to put pressure on the suppliers of LIMS systems to get to a centrally served system. So back in the early days, the history of LIMS, if you look at the genesis of LIMS to begin with, in the early 1980s, Beckman Corporation came out with one of the first LIMS systems. And LIMS systems were generally devices to try to trigger instrument sales, things that they had very well measured and understood margins for. And the companies that supplied them early on, Beckman, VG, P.E. Nelson, and so forth, Perkin-Elmer, they figured that if they supplied the ability to acquire and process data from their instrumentation, that it would draw people to buy more instrumentation. Then over the years, we started to see vendors appear that were pure play LIMS vendors that had nothing to do with instrumentation. But all those systems were based as client-server systems over the years. First, they were basically on terminal server applications that were in the client-server environment. Then as the GUI improved for these LIMS systems, they became more sophisticated. The abilities and functions that were presented to the user base started evolving greatly in the late 1990s. And by 2000 is when we started to see a great move toward the centrally served systems. So what was once a desire, meaning the agreement to harmonize and normalize operations across multiple sites in a client-server environment, once you get to a centrally served environment where everybody's operating off the same LIMS image, now it becomes a requirement because people are working and executing their daily duties off one image of the system. And so the workflow has to be able to accommodate all of the different needs of all the different sites. So we already discussed the fact that economic pressures drive the need for support. Economic pressures are also driving the need for LIMS in general due to the fact that in many cases it supplies the ability to be more productive. In regulated industries, it supplies the customer the chance to be able to employ their compliance policies. So harmonization means different things to different people. And it's an overused term these days. It's a buzzword in the industry. And you'll see it in PowerPoint presentations dealing with anything and everything. But so we should establish our frame of reference for the purpose of this discussion today. First of all, it's a methodology for looking at the current operational state. We call that the as-is state. Back in the days, as I mentioned, with Digital Equipment Corporation, when we were forced to develop this strategy, we coined the words for as is and to be, but in parallel with other organizations in workflow analysis and so forth, they just seemed like logical terms to use. But we did use them in presentations as far back as the late 1980s, around 1987 or 88. A look at the as-is environment, the current state system, is necessary because it's sort of a barometer of where you want to be. We're going to see detailed examples of workflow and the way we target system functionality for LIMS deployment in just a few minutes here. What we do want to do is understand that harmonization and workflow analysis, they not only deal with things that LIMS brings to the table, because process improvement will only partially involve any software that's brought to the picture, but also looking at a chance to improve operations in any kind of an environment. Every time over the years that we've done current state environments and worked through this process, people understand that there are process improvements that we have identified with the help of our users, our customer experts, that bring some sort of relief to some of the bottlenecks that are in the processes that previously were never addressed. And in some cases, it very much helps to have, if you don't have independent consultants working on this, it helps to have people using a methodology that, as I said before, is somewhat abstracted. And so therefore, you appear to be a little bit neutral. You're not getting into the kind of parochial aspect of one site portraying their methodology and operations as superior over another. If you can bring it back to the business needs of the organization, that gives you a great ability to be able to drive the process in such a way that people can't just grab onto what they know. So it's also a normalization of testing processes. Whenever possible, what we want to do is try to have the same kind of testing methodology. Now, understanding, if you have multiple deployments across different countries, you might have different things such as how reporting units are portrayed and so forth and identified. You can account for those kinds of differences in your future state environment. That's not a problem. But to the extent that you can, it's very much desirable to have the testing processes more or less normalized. So we want to make sure that things are operating the same way every time. Now, where the differences typically will appear are how samples are handled at specific sites, because there might be certain constructs within the site itself and how samples are brought to a laboratory and how they're logged and so forth. And we'll be talking about those when we get down into the workflows. Now, one of the big opportunities that avails us when we're in this process is that when we're looking at the current state environment, we're going to be able to identify process improvement opportunities. What's really helpful there is that you're able to use the people in these groups where you're identifying the current state environments and proposing a straw model 2B environment. And again, we'll go through the process in detail. But you can believe that if people have been using a system for years or using a process, even a paper process, they will absolutely have opinions on how to improve that process. And nothing is better than having a forum for those people who have been basically suffering at the lines of infantry, the folks that work up from the lab level, that work at the sample handling level, that work at the reporting, the review level. They will certainly be able to tell you what kind of things burn up their time in a day. And so we have that opportunity in a future state environment to get rid of some of those things that burn up time and help make people more productive. So overall, this is a roadmap for business-driven success, and that's not just a fancy term or something that looks good in a PowerPoint slide. If you think about the complexity of modern-day LIMS systems, the fact that these systems have a great deal of functionality, as they have to, because LIMS systems have to be applicable across a broad cross-section of industries. So it's very difficult for a mainstream vendor to say just support microbiology or just support petrochemical or just support pharmaceutical. They have to have a system that's malleable enough to be able to be configured for each one of those environments. But as such, because all of that functionality is available, there's only a certain subset of that functionality that's applicable at any moment in time for a particular industry. So by using a process that's rather surgical in the identification of those elements that brings business benefit to a particular company, by looking at the workflow elements that relieve wait states and relieve workflow bottlenecks and those kinds of things, we're able to identify those opportunities that we prioritize during the project deployment. That way we make sure that when we properly utilize our budget for those things that bring the biggest business impact, if there's budget that becomes available over a continuum of the project, we can defer items that are not as critical to second and third phases of the project. But a roadmap for success means that we're identifying those things that bring the most benefit immediately. So the high-level objectives that we're looking for here in a harmonization exercise is the identification of clear requirements. So it's not just, if anybody that's ever had the opportunity or the privilege of being involved in developing requirements or RFP for vendor demonstrations and those kinds of things, unless you have experience with these systems, it's very difficult to separate requirements that are capable of differentiating between different vendor offerings or capable of being identified as those things that are high business priorities. So we'll show a process today that helps clearly identify those requirements. And of course, as we spoke about before, we want to reduce differentiation between sites. To the extent that we can do it, the greater that we can normalize operations between sites, the better we can have those benefits of reduced training costs, reduced support costs, and increased productivity and transportability of the resources. We also have a decreased implementation time for the reasons I mentioned a few minutes ago. If we constrain our deployment to those things that bring business benefits, we're not implementing functions that are only used 5% of the time. At least we're not doing that in the first phase. So when we go about expending our precious project budget and so forth and developing a system, we're really aiming at those things that bring the greatest business benefits, so we execute those first. That allows us to expedite the project implementation time. Now, this is something that needs to be communicated because there's sometimes a lot of resistance to upfront planning in terms of workflow analysis and harmonization. And the reason being is that when people are sitting on keyboards and developing functionality and those kinds of things, they're viewed as being productive. And the truth of the matter is a little bit of upfront planning will reduce that implementation time. So planning up front will actually decrease implementation time, but sometimes it's a little bit of a harder sell. So the process involves the identification of the current state environment, and we're going to talk about the specific elements of these things in just a couple of minutes. But generally what is happening is that there's a capture in a group environment, and that is a capture of the current state environment. Now, generally the easiest way to do this is using whiteboards and actually drawing the workflows. That's because tools such as Visio, in terms of being able to define workflow, while they're very nice and they come into play later, they're too hard to work with in real time. So the absolute best way to do this is on a whiteboard and developing the workflows. So it takes a little bit of facilitation skill to draw out the requirements at the proper level, and we're going to be discussing the as-is process in just a moment. Once we have developed these as-is requirements and refined the workflow in Visio, we need to go through and look at, make sure that we captured all of the detail. Invariably, when you pass around as-is workflow diagrams, even to the groups that you've just interviewed for a couple of hours at a time, when they actually see these things in black and white, it becomes extremely apparent that there were things that were missed, things that were not captured properly, not identified. So probably out of order, out of sequence. Those are all opportunities to refine these as-is models. We'll talk about the construction of the future state environment. This is your opportunity for process improvement. It's an opportunity to fix all those things that the folks have complained about in terms of productivity killers, ways to do things better. And so we'll examine the to-be process in the course of this presentation in just a little bit. To-be refinement is the last step in really nailing down the model. And we'll talk about the fact that to-be models actually zero in on functional elements that help bring the to-be model into play, and how that actually works in terms of defining specific requirements. Once everything is finalized, you're able to now develop a project plan. You're able to, the fact that you've identified project priorities, you're able to construct plans in tools such as Microsoft Project that highlight those elements that bring the greatest business benefit. Those are earlier in the project plan. Those are in the first phases of the project plan. And this is how we try to economize the overall execution of the project. The fact of the matter is that current state environment, for good or ill, is the key element in understanding how far it is that we have to move to get to an optimal future state environment. And so we talk about as an honest look at the current state operations. Now, there's a phenomenon that we've examined over the years and witnessed in a number of different customer accounts, that if you sit down in a room with a number of customer subject matter experts, and let's just use an operation such as wet chemistry. If you have the right complexion of people in those interview sessions when we're developing the current state workflows, you're going to get the people that believe they know how the process is executed. And these are typically the managers of the laboratory operations or supervisors or maybe a level slightly higher up. And often there are a lot of surprises in these sessions, because when people at the bench level who actually have to perform the work on a daily basis, when they start to describe actually what they do, invariably there's a case where the supervisory or management personnel had no idea this is actually how work was being done. So for no other reason, if you go through this kind of an exercise, it's an eye-opening experience for everybody, because people will understand how work is actually getting done. One of the phenomenons that sometimes the management folks who are a little bit distant from the lab don't understand is that users are going to work on things in whatever methodology makes life easiest for them. And that's not to say that they're trying to skip work or bypass or shortcut. What they're going to do is they're going to find the way that makes them more productive. And so sometimes there's what we call black market workflows, and that is people are handing things off directly to people to get things done. There's a certain handshake agreements and so forth for how the actual work is getting done in a day's time. So by diagramming these things out, suddenly these things become very visible, and it's very valuable to be able to look at these things. The level of detail is very critical in capturing the as-is environment, because if you get too low of a level of detail, and frequently when we look at workflows that have been constructed by customer-level resources, they're generally too high of a level. What we see is an entire operation on one page. We'll see the wet chemistry lab or microbiology described on one single page of paper in very high-level blocks. That's not a level of detail that allows the ability to refine that workflow and look at the process steps. And we'll see the exact level of detail that we get into. It's critical to capture the productivity killers, such as wait states and other elements where people are not automatically notified of work to do. And we'll see an example of that. So from a process note standpoint here, what we look at in organizing the as-is sessions is we try to organize by work groups. So when we say work groups, it could be wet chemistry, microbiology, dissolution, incoming or raw materials testing, in-process testing, final release, QA, QC. All of these things are fair game for the different groups. You want to keep the groups small because too big of a groups are intimidating and only a few people will be doing 95% of the contributions. We like to say 4 to 6 people is usually a good number, but they have to represent the wide context of the operations in the lab, meaning they have to have people that actually do the bench level work, but actually do the review work and say the release of documentation and so forth. The to-be designs are constructed as a straw model. The big difference between as-is capture and the to-be design is that you do work in groups in the as-is process because you are drawing out, for good or ill, the complexion of the current state environment. That doesn't work so well in the to-be environment because if you get in there and try to brainstorm, you're going to have people of all different levels, all different understandings of applications and technology, speculating on how best to do things without knowing how the software can be applied to alleviate the kinds of problems that we identified in the as-is state. So it's better to have a very small team designing a straw model, a to-be model for challenge. And what has to happen is when you develop a to-be, so there's a few people off in a vacuum developing Visio models of the to-be environment, projecting the changes. Now you've captured some of these notes during the as-is process of things that can be done. So now you have a small group developing the to-be models, and they go and develop a model for challenge. That is the absolute best way to do this because when you get these to-be models up in front of the same very groups that you had in the as-is reviews, in the as-is development, now they look at that, and in black and white, anybody can read a flowchart. And they look at these things, and it is the surest way of connecting the process to these diagrams and what's actually happening. So you have to be able to go into these to-be design challenges by telling people, look, we're not married to this. These are just a tool for being able to review the future state environment, and we need your input. We value your input. Nothing is sacred here. We're going to be looking at this, and we're going to be working as a team together for this. So let's examine a typical workflow. And here I've taken just a very small operation, and we're calling this the lab work to do workflow. So in this case, I want to make sure that you're focused on the fact that, and this is so common in many, many laboratory operations, one of the first things that we do in looking at the current state environment is we tell people, okay, here's the starting point. How do you know that there's something to do when you show up for work in the morning? And people kind of look at each other, and typically you'll see people saying, well, we have a certain bin in the lab. And we walk over there, and usually the people from the sample prep groups or sample delivery groups have put samples in these shelves. We kind of look through these samples, and we figure out which ones we want to work on. We take them to our desk. Or they walk over there, they get in the early morning, they look, and there's nothing in those bins. The sample delivery people haven't shown up yet. So what happens? Well, you ask the questions, well, have samples arrived yet? They look, nope, no samples there. Guess I'll go grab some coffee. The very important thing is to look what happens in the no branch of this workflow. There's a wait state. And if you think about it, in the current state environment, you don't know when you go off on that coffee break if the samples arrive 1/10 of a second after you leave the laboratory, or if they're going to arrive an hour later. And we'll talk about that. So you're waiting for those samples to appear. We actually worked in a large laboratory one time that had a massive laboratory operation, but it was far distant from the sample receiving area. And so they actually had webcams trained on these bins where the samples were delivered. And so people would log into a URL on their computers and see if something was visible from their webcams. So it was kind of a quasi-automated state. They would log in and look. It just saved them to walk over to the bins. So in this workflow, if there are samples, once they do find that samples have appeared, they start to go through the process of trying to determine what the required testing is. This may require pulling methods or SOPs from a procedure book or something. They might have a certain results entry sheet that they need. Only at that point are they starting to prepare reagents, maybe calibrate instruments, preparing mobile phases, those kinds of things for chromatographs. They might be going and rounding up the glassware that they need and so forth. And they go through and refine the testing that they're going to be able to work on that day, and they begin the testing, and we go off page into a testing workflow here. So as I said, these workflows are for good or ill. I mean, it is what it is. So looking at this, one thing that becomes obvious to us was that wait state. And this is as we look for opportunities for process improvement. We think, well, what could a commercial LIMS bring to the system? And when we design the future state workflow, what we want to do is retrospectively, we look at the as-is workflow for things that kill people in terms of productivity. And wait states are the most glaring example of this. Anytime you're waiting around, you're not getting push notifications of work to do. And by the way, this could apply to supervisory workflow. We could look into workflows where work has been done, results have been generated. And in a paper world or a semi-automated world, result reports may be piling up in the inbox of a supervisor. And a supervisor knows that they have work to review when they look at their inbox and see a pile of work to do. And they're manually going through, cranking through these things. And so there's another case where they're waiting for work to appear. We want to automate those kinds of notifications to the extent possible. So we're looking for those opportunities to identify places where we can improve the process now. So with a good eye, we can look at the level of detail here. And one thing we mentioned a few slides ago was making sure that these workflows were dialed into the right level of detail. So here we know that we're walking over to a sample shelf. Gee, we know that we can improve the situation here. That's a sure low-hanging fruit for us. We look at also other time eaters. Determining required testing. Is there a way we can electronically be notified of the tests that are assigned to that sample? Is there a way we can look at a electronic template for results entry? And of course, there is the glaring wait state. That is the most obvious. We want to attack that one first. So as we look at the same state now, we're going to look at a straw model. Remember, as we talked about this a few minutes ago, in looking at the 2B operations, and we want to do this as a straw model. And so we're going to look at this 2B state. So in this case, we look at, if you look at the wait state that we had, the second box from the top in the center there, it says check a LIMS dashboard. So we've designed a proposed environment where LIMS will have a dashboard that when I log in, I come in the morning or even the night before, and this is going to be critical in just a moment. I log in the morning, I see how many samples have been assigned to me by my supervisor, and I can see what work there is to be done. That is a push notification. I know of this. I'm not walking by that bin anymore looking for samples. The work is being pushed to me. If you think about it, if things actually are automated to the extent that samples are logged into the system, or maybe some sort of lots have been triggered in the LIMS system the night before, there are a lot of things that we do when we have dead time in our normal laboratory day. if I know that work is coming tomorrow morning, and I know that I can't do the work till tomorrow morning, but maybe I have samples running on auto samplers and things like that, maybe I can start to get that glassware prepared the night before. Maybe I can generate barcode labels for glassware to be collecting samples and so forth. Maybe I can mix up some reagents or mobile phases I'll be needing for the next day. So we look at all those kinds of things as things that we can improve productivity in. So we now look at, in the future state environment, and thinking back on what we had in that current state environment, we look at sample delivery workflow. So we have a separate organization that is logging samples in and bringing samples to the laboratory. We look at the place that the assigned work is going to include all the samples that are going to be coming in. It's going to identify all the tests to be done. Remember, in the as-is workflow, we were dragging pieces of paper to look at this, or we're pulling them out of Excel spreadsheets or something like that. So in this case, we're looking at samples, the tests, the instruments that are going to be used. If you're really good and have really thought about your LIMS implementation, you can do workload balancing on those instruments. We look at any opportunity for doing tasks in parallel. So these tasks in this example are made and we can do these in parallel by the fact that advanced knowledge of the work to be done allows us to do these things kind of offline prior to the samples actually showing up. If the problem is that in the old workflow, the starting gun didn't go off for the day until the analyst looked and got their samples for the day. If we can fire the starting gun the night before, and a lot of these things become known, we get a jump on the next day's worth of work. We also look for the fact that wait states can be eliminated due to automatic notification of the samples in the lab. So all of those things about obtaining locations, we can look at the location of the samples if they're in a special room or something like that, because they've been logged in usually by barcodes, by sample delivery people. So we look at all of these things when we're developing a future state environment. So now we talk about harmonization, and this workflow looks rather dense and so forth. But in this case, what we're trying to exhibit is the fact that in an absolutely perfect world across many sites, we would have site A being identical to site B, being identical to site C, being identical to site X. And that's usually not the case. There are certain nuances based on the actual physical geography of the laboratory or something like that, or current state operation that requires there to be some nuanced differences. In this particular diagram here, what we're looking at is differences that exist between two different laboratory operations. I've chosen site A and site B. And you'll see that on the left side and the right side. The red boxes on the right show that at site B, a couple of things are done a little bit different in the sample delivery cycle. Okay, those really can't change because this is the operation. Let's just say that they're rather rigid in their workflow at site B. Those boxes in red to the right are all different from site A. They have a whole different sample prep team. Maybe there's a whole team that does nothing but sample preparation. Maybe they do instrument calibration, reagent preparation, those kinds of things. But what is common between these two sites are the things that we're trying to look for easy harmonization. To the extent that we can identify those functions that can be consolidated across sites, those are the opportunities to do actual normalization of the processes. So in this case, the yellow boxes are those things that we're just going to have to live with. The previous, in this case, the previous box. We saw those areas that were in red. Those are things that we're going to have to live with and just agree to be different here. But in the environment where we're looking for the absolute harmonization, these yellow boxes here, they identify things that there's no reason in the world why we couldn't do these things the same between sites. So when you're developing that future state environment, usually there's some give and take here. So when you're looking across sites, and we usually are sharing as-is workflows and to-be designs across multiple sites, when we do this work, we typically might visit different places. In some cases, it's visiting a place across town. In other cases, the more complex ones that we've done in our careers, we've visited 6 or 7 different countries. For the most part, it's usually involving a couple of different sites, but making sure that you can get people to agree on the future state environment. When you're looking at future state environments, it's nice to have representatives from multiple sites at one place. If it's at all possible, if you can have them under one roof at one central site, then you can talk about the differences and try to, through facilitation, arrive at workflows that there's no good reason why you can't do things the same way at both sites. So we look at the major elements that can be harmonized, while the site-specific nuances that we identified with those red-labeled workflows earlier. We identified that those things can exist as differences, but we try to identify as many things as possible that are consolidated across the environment. So if you look at this diagram closely, we've identified those things that are the same. We've also identified, if you look at these arrows here, what we're looking at here are what are the things that software brings to the table versus what are things that are process improvements. In looking at this workflow very carefully, you'll see that there are elements, for example, in the sample delivery workflow on the right for Site B. Those are things that have nothing really to do with LIMS, but they have something to do with process improvements that, just operationally speaking, can be brought to the table. And so there are things that you can do to improve processes that have nothing to do with LIMS. In this case, these arrows here point toward the low-hanging fruit of things that can be addressed by LIMS. For example, on those common elements on the left. And we're looking at, they're slightly different between sites A and B. But on the left, we're looking at the first arrow points to sample locations that are entered into a LIMS receipt screen. So in this case, we're envisioning that there are barcodes on samples, and you have a sample receipt screen. And so when a sample delivery person or a laboratory person accepts samples from a delivery group, when they scan the barcode, the sample location is also recorded by scanning the barcode. So we know exactly where that sample is going to be stored, whether it's in a room, on a particular shelf, in a bin, or whatever. That's something that can be done electronically within LIMS. We look at process improvement. The second arrow points on the left side, points toward a LIMS dashboard. That is the backlog report for a laboratory person that they can understand what work is to be done for a day. We look at the assigned work is automatically displayed now. So we're presuming in this case a supervisor in advance has done assignment of work, or that certain work is assigned to a particular laboratory entity. So now it's displayed automatically. We don't have to hunt up that work. We don't have to try to figure out what we're going to do in a particular day. The last arrow on the left side shows that the analyst obtains the shelf locations and retrieves the samples and those kinds of things. All of these arrows are pointing toward the low-hanging fruit for what LIMS brings to the table. On the right side, because the workflow was slightly nuanced, slightly different, we show where an analyst actually receives the samples via barcode. On the left side, it was a sample delivery person that scanned this stuff in. On the right side, just the geographical nuance was that an analyst received these things and is bringing these things in. And scan them into the system. Again, the second arrow refers to you're checking the LIMS dashboard. You're looking for the assigned work is the third arrow. The analyst reviews the required testing. All of those things on the right side are workflow that can be accomplished with the advent of LIMS. So in understanding the process completion task, it's important to understand that we've identified the functions that can be converted by developers. So those LIMS functions that we talked about here, that I've got the arrows pointing to, we've identified those. Now the folks that are the experts in deploying LIMS, whether they're company experts that you have, whether they're vendor resources, whether they're consultants or whatever, you've identified those things that bring business benefit to the company. So the developers are now challenged with implementing these functions inside of LIMS. So if you think about the whole continuum of the process here, we went through the as-is environment for the purpose of understanding, as I said, for good or ill, for good or bad, we've identified how the process works in the current state environment. And one phrase that we commonly hear from customers when we do a current state environment diagram is, boy, we didn't realize how messed up our workflow was. And that is a great mechanism for stimulating conversation and catalyzing future state development that helps you identify productivity gains. You've used people that are closest to the work. You've used people at the bench level that understand how work actually gets done. You've used people that understand how work is checked and released. If you think about it, in the LIMS world, some of these boxes could, in a future state, in a current state environment, you might have a paper environment where somebody, a supervisor, maybe with a master's degree or a PhD, is checking basically middle school algebra to make sure that calculations were done, to make sure that data entered was properly entered, that somebody didn't write something down that was crazy like a pH of 17 or something like that, or that they did a wrong subtraction to get a net weight for a balance section or something. So those kinds of things that we can aim at LIMS solving brings the ability of software to do those things that have the most potential for errors and so forth. We always look for opportunities to eliminate errors in transcription. That's why instrument interfacing is so popular, because it provides a mechanism for moving data from laboratory instruments. There's no writing down of the data in intermediate result sheets and those kinds of things. And so that data is moved across into the LIMS automatically. Because we've validated that functionality, that it works every time in exactly a precise manner, we know that we don't have to worry about it anymore. If we do things like in the LIMS world, trapping erroneous entry ranges, as I said in the example of a pH of 17, we can trap that the instant an analyst tries to enter that. So if an analyst mistypes 17 when they meant 1.7 for a pH, it's echoed right back to them immediately, and they make that correction on the spot. In a current state environment or an Excel spreadsheet or something like that, that entry could have gone through there. What happens? A supervisor catches it, sends it back for correction and initialing and change and so forth, and it adds to the overall productivity killers. So in going through this process, when we got to that future state, through very carefully facilitated actions, we developed the future state model, such as the one we're looking at, that while we are cognizant of the nuances of geographical differences between sites, we also have argued and finally agreed upon, negotiated, whatever you want to call it, things that we can do the same across multiple sites. So those are the normalized functions. The fact that we've identified differences between the sites still allows us to develop a harmonized model. With the advent of LIMS, it's brought all of these productivity increases to the operation. So the design elements that we identified, when we looked at those functions back in the previous slide, I'm sorry to jump back and forth here, but it's, again, important to look at the LIMS functions here. If we look at these LIMS functions in a real world, remember, this is only the sample delivery cycle that we looked at. You're going to have this replicated across raw materials testing, across in-process testing, across supervisory review, across sample relief, environmental testing, environmental monitoring. If you're in regulated environments, perhaps you're producing products that have sterility requirements, so sterility testing. There's all sorts of labeling of containers to go around to different places, sample and do swabs and those kinds of things and bring them back. There's microbiological testing associated with that. So if you think of all those laboratory groups, you're going to have these kinds of workflows replicated across many different organizations. So while we've taken one small little sampling here, what I'm trying to make sure that you look at in your own work is that you're looking into all of these different organizations. You're looking for all of these different abilities to apply LIMS to alleviate certain problems. You're looking for those areas that have nothing to do with software whatsoever for process improvements. And so at the end of the day, when we go across all of those organizations, we're able to prioritize those things that bring the greatest business benefit to a company. And we can then sequence them into the project plan so that those things that should be in phase one are done in phase one. Those things that can be pushed to latter phases can be pushed off to those phases and executed when the budget becomes available or whatever for those things. So the project plan is then executed, and the future state environment is developed. The project plan is executed. We're at the stage where all of the deployment work and configuration work is done. And if we've done all of this right, we have surgically produced a design that allows us to have focused on business benefits and not specific parochial preferences of particular sites. Things that users believe they need because it was in their current state, whether a paper system, whether Excel spreadsheets, whether old software or whatever, things that they did not want to let go of. As we've abstracted this to look at the workflow from a business perspective and gone through this prioritization process, we've now reduced this to a business argument and not something that is biased toward a particular site's operations. So with that, that brings us to the conclusion of the core of the presentation. And we'll start looking at some questions and so forth, Jack.
Thank you very much, Randy. I'm sure you will all agree there are some excellent points raised during the presentation, so please feel free to send in your questions. We have had a number of questions so far, so I'll move straight on to these now. How long should we expect harmonization to take for our company? We have 3 sites.
So in a case of a 3-site, if you think about the different groups, what we generally say is that when we have a group in a room, let's just use the example of the microbiology group. Okay, so the microbiology group, when we get a room with the microbiology experts in the room, it generally takes about 2 hours per group to capture an as-is workflow. Remember, we're capturing this on a whiteboard. When we have time offline a little bit later, we then convert those workflows from, and we actually take photographs of the whiteboards with digital cameras. That's the fastest way. Over the years, we use different tools that automatically capture. There are fancy whiteboards out there that do printing, but at the end of the day, we found out that with today's inexpensive digital cameras, that if we take pictures of workflows that have been drawn on a whiteboard, and we now have an indelible record of those workflows, we can go and work offline and convert those into Microsoft Visio. You obviously don't want to send hand-drawn workflows around for people to review. So once those are rendered into Visio diagrams, then we actually email Visios around or maybe review in group sessions those workflows now in the Visio environment. We generally, what I didn't do on my workflows for the example is we always number the boxes in Visio. That way when people are reviewing them, they can say, hey, box 2 connects to box 6, and that doesn't really work that way in our laboratory. And by the way, box 17 is mislabeled. Box 25 shouldn't even be there. It's a very, very easy way of identifying exactly what they're talking about. And so it's important to label the boxes and have a feedback mechanism established for how those get done. How does that affect the time? The current state capture generally takes about 2 hours per laboratory group, and generally that holds true, plus or minus like 30 minutes. So maybe particularly complex operations, something like that might take 3 hours, but in general I would say 90% of the time a particular group takes about 2 hours to capture. It should take, with somebody that's fairly good at using Visio and so forth, it takes usually about an hour to 2 hours per workflow to really refine the whiteboard captured photographs into Visio. It takes another hour for groups to review the as-is workflows. The 2B environments generally take almost a day per group. So if you had 5 groups and say you might take 5 days to do the future state environments and develop the straw models. The review of the 2B models actually goes quite quickly because you've sent the 2B models by email in advance of the 2B review sessions. Again, it's much, much easier to do these live. So all those people that participated in the as-is sessions, you bring those people back into the room after they've already looked in their own their own time. They've looked at the 2B session. They've made all their notes. They've scribbled on them. Now you come back in and you fight it out in the same room. You look at these things. You project them up on a board. You start to real life make adjustments to these workflows in real time. So that takes generally, you can review almost all the, if you have, say, 5 different work groups in a site, you can review 5 different 2B workflows in a matter of an hour apiece, maximum 2 hours apiece. But usually the 2B workflows, because people have reviewed them in advance, they go much quicker. So for 3 groups or for 3 laboratory sites, taking a couple of days and so forth to develop all these flows, the rough time from start to finish, from the beginning of capture of the as-is environment to the final approval of 2B for a 3-site company with, say, 5 groups per site, you can get all this done in about 4 weeks' time.
Thank you, Randy. The next question that we have is, how do we harmonize between internal and external use? We have users who are outside of our firewalls.
Yeah, so there, and in many cases, and this is one of the beauties with centrally served systems that are accessed by web browsers. Usually they're role-based systems and so forth. So if you're talking about external being geographically external sites, or if you're talking about external users, meaning people that may be data consumers and so forth, you can still do workflows that involve those folks as well. Now, in those 2 cases, because I didn't understand the context of the question exactly, if you're talking external, folks that are external to the central site that are using the system, but they're part of the same company, there's no reason why you can't share the whole context of the workflows with those folks and capture offline what those people need to have in a system from an external standpoint. But if they're people that are outside the company and you don't want them to view the inner operations of your site, you can limit the capture as far as what they need to have as far as submitting, for example, samples to a system and looking at data at the tail end of it. But they don't have to review those workflows that have to do with the operations that are internal.
Thank you, Randy. The next question that we have is, how long does a typical implementation take?
So typical implementation is unfortunately, you have to answer a question with a series of questions. In looking at a site, let's look at a Acme pharmaceutical company, and they're coming off a complete paper environment or an environment of homebrew software, Excel spreadsheets, and those kinds of things. And let's just say that they have 5 different laboratory groups that are participating in this sort of an exercise, and you're deploying the LIMS across 3 different sites. Well, it's going to be faster in a harmonized environment with centrally served web browser access system because, remember, we're trying to consolidate the workflow at the design phase. And so people are going to be more or less doing the same processes across all those sites. So I think a LIMS vendor, what I've described as a major implementation, a major pharmaceutical company with 3 different sites, with 5 different work groups that they're addressing and so forth. In those cases, I think the fastest that could be done in terms of implementation is probably about 8 months, and probably at the top end of that is probably going to be around 18 months. That probably doesn't include validation, because in validated environments and so forth, validation is like stereo equipment or whatever. You can spend as much money and time on validation as you want to. Companies that are more risk adverse will have greater validation needs and more stringent validation requirements. Sometimes that can consume a third of the project time and budget. In other cases, validation is much easier, or some companies are not in environments where they actually validate at all. So validation can add a third of the time to those figures I mentioned, or if there's no validation, you're probably at the lower end of that implementation curve.
Thank you, Randy. We still have time for a couple more quick questions. The next one that we have is your system sold as validated?
There's no such thing as a system that can be sold as validated, because validation is the responsibility of the customer. And let's talk about it in terms of, say, FDA validation or the European equivalent and so forth. a system can only allow you to execute your validation procedures. But at the end of the day, the actual physical execution of the validation scripts, the signing off of the validation documents, those are all the responsibility of the customer. So the best a vendor can do is provide the tools to allow you to implement your validation policies and allow you to have all of those things in place. Now, if we're talking specifically about things like 21 CFR 11 or something like that, you're talking about tools that are available to accommodate those regulations, such as electronic signatures, such as audit trails and those kinds of things. But how you actually show how the audit trails are being monitored, how are you actually showing how the electronic signatures are being applied, those are all part of your master validation plan and part of your validation scripts and testing. At the end of the day, there's no such thing as a validated system that is sold by a vendor.
Thank you, Randy. The next question that we have is, in pre-analytical and analytical phases, any system rules recommendation incorporated into future state workflows for efficiencies?
Well, so pre-analytical and analytical phases. So pre-analytical, let's just say that is that's going to be like the sample raw materials testing and those kinds of things. Things that are getting samples ready to deliver to the lab. We love to have people out there in raw materials or incoming materials divisions actually doing sampling and logging things into LIMS at the raw materials stage. So out there at the loading dock or whatever, the reception dock, folks are logging in samples and per protocol, they're sampling things right then and there. They can log those into the system, and the people in the laboratories will be notified that there are raw materials that are going to be coming in to be tested. In some cases, in production environments, let's just say a truck pulls up with a load of ethanol that has to be tested before the truck can be released. So you want to highly prioritize that kind of sampling, right? You'll want to take a sample off that ethanol truck, go through the quick test out there, and then say, okay, this is what we thought it is. It's great. The truck can take off. And so that's a great help in the pre-analytical phase. Analytical phases, well, those are many different flavors. I mean, I think I gave some examples of how to look at different workflows. Again, it's a matter of incorporating all of the different analytical groups, dissolution testing, microbiology, wet chemistry, those kinds of things, and looking at those workflows in great detail.
Thank you very much, Randy. Unfortunately, that's all the time that we have now for questions, but anyone that didn't get answered will be sure you are contacted offline. The webinar will now be made available on demand. If you have any friends or colleagues that you think may be interested in this webinar or any future events, please feel free to share the link. Thanks again for your time.